In this video, we're going to go through three-dimensional trigonometry. The hardest thing with three-dimensional trigonometry is finding the correct right-angled triangle that enables you to use Pythagoras or the trig ratios to solve the problems. So let's go through some examples. Example 1. This one involves a cuboid. So 1a. Find the length of AG. So if we look at our diagram, we're going to go from A to G. So if I draw a line from A to G, I can now find a right-angled triangle that involves AG. So if I go from G to C, and then from A to C, I have a right-angled triangle. There is my right angle there. So if I draw that right-angled triangle, I've got, here it is. So that's A, G, C. And I want to find AG, so I'm going to call that X. GC is 3 centimeters. I haven't got AC, but if I look here, let's change colors. I've got that right-angled triangle there. That is actually a right angle. I know it looks as if it's not, but it actually is. So if I now draw that triangle, so let's draw it in blue. So I've got A there, I've got C there, I've got B there. So AB is 5, BC is 6, and we'll call that Y. So I can use Pythagoras. So Y squared is equal to 5 squared plus 6 squared. So Y squared is equal to 25 plus 36. So Y squared is equal to 61. So Y is equal to the square root of 61. I'm not going to find the square root of 61 because I know I'm going to use it again using Pythagoras, so I'm going to square it. So if I go back to this triangle now, I know that AC is the square root of 61. So I can now find X. So X squared is root 61 squared plus 3 squared. So X squared is 61 plus 9. So X squared is 70. So X is the square root of 70, which is equal to 8.3666. Part B, find the angle GAC. So if I go back to my diagram, the angle GAC is this angle here. So we'll call that theta. So if I draw myself a little triangle, GCA. So I want to find theta. I know that AC is root 61. I know that GC is 3. So using my trig ratios, I know that tan theta is equal to opposite, which is 3, over adjacent, which is root 61. Therefore, theta is tan to the minus 1 3 over root 61. So theta is equal to 21.0 degrees to 3 significant figures. Question 2 involves a square-based right pyramid. So question 2a, find the length EM. So we want this length from E. Let's redraw that. So we want a length from E to M. So we have now got a right-angled triangle there. X to M is half of 20.6, which is 10.3. We'll call that X. So A, we know that X squared is equal to 14.75 squared plus 10.3 squared. So X is equal to the square root of 14.75 squared plus 10.3 squared. So X is equal to 17.99. So X is equal to 18.0 to 3 significant figures. Part B. Find the area of triangle EBC. So if I draw the triangle, let's quickly, EBC. I know that the base is 20.6. I know that the height, because I've just found it, I'm going to use 17.99. So the area of the triangle, so triangle equals a half times 17.99 times 20.3. So the area is equal to 182.5985. So the area is 183 to 3 significant figures. The final part of the question C. Find the angle between the line EM and the plane ABCD. Well, the plane ABCD is the bottom of the pyramid. And if you imagined you lent a ruler along the line EM, and you want the angle between the ruler and the plane. So what he's actually asking for, let's change colour, he's actually asking for this angle here. So if we draw a triangle, just to illustrate this, we've got point 3. We'll call the angle theta. We know that the height is 14.75. So we can use tan. So tan theta is equal to opposite, which is 14.75, divided by the adjacent, 10.3. So theta is equal to tan to the minus 1, 14.75 divided by 10.3. So theta is equal to 55.1 degrees to 3 significant figures.